Hey guys, today we're going to talk about planetary wind belts. So, if you go on reference table page 14, you should see something like this. Go ahead and open your reference table. And a major vocabulary word you need to know for this topic is prevailing winds. And a prevailing wind is a wind that blows predominantly from a single general direction. When we talk about prevailing winds, we're talking about the major wind belts throughout the world. These are our major wind belts. These arrows show which way they're going and which way they're coming from. We call these winds prevailing winds because they blow in a certain direction or predominantly in a certain direction, depending on the latitude. And this affects our weather and climate throughout the whole world. Okay? And what causes winds? Winds are caused by the Earth's rotation and in the unequal heating of the atmosphere. It's caused by the Earth's rotation because remember, the Coriolis effect occurs because of the Earth rotates, right? And since the Earth rotates, when winds try to go straight like this, instead of going straight, they kind of curve towards the right side in the northern hemisphere, and towards the left side of the arrows in the southern hemisphere. That's what we call the Coriolis effect. And the winds are caused by unequal heating of the atmosphere, because since the sun unequally heats the world, different parts of the world, we have places of high pressure and we have places of low pressure. And remember, winds blow from high to low pressure. So two things that causes winds: Earth's rotation and unequal heating of the atmosphere. So this is already given to you in your notes. Planetary wind belts are caused by the unequal heating of the atmosphere. You can also write down the Coriolis effect or the Earth's rotation on the side if you'd like. So go ahead and pause this video. Try number one. The planetary windmills in the troposphere are primarily caused by the what? The correct answer is A. The planetary windmills in the troposphere are primarily caused by the Earth's rotation and the unequal heating of the Earth's surface. Okay, so if you look closer on this diagram on your reference table, you'll see that some places are labeled wet, dry, wet, dry, wet. So we can tell that some parts of the world are more humid or wet, such as rainforests, and some parts are have a dry climate, such as deserts. So in areas with high pressure, such as these areas, 30-degree north, 30-degree south, and even the north and south pole, as you can see, notice that our air in these areas are actually sinking, right? So in high pressure area, if you were standing on this part of the earth, you would feel the air pressure, air sinking because it's a high pressure area. It's also sinking on this side. And in this high pressure area, the air is sinking, as you can see, and the air is sinking here. That's why these areas are dry because remember, if the air sinks in a high pressure area, we can't really form clouds, right? So that's why the air is dry in those areas where we have high pressure. In high pressure areas, we have diverging winds, meaning the winds are also moving away. Remember, winds blow from high pressure to low pressure. So winds are always blowing away from the high pressure area, right? So notice that in high pressure areas like this in 30-degree north, winds are moving away from the high pressure area. Same thing over here. Winds are moving away from the high pressure area. These arrows on the sides are showing convection currents in the atmosphere. So this part of the earth is the land part and the arrows on the sides are showing what the air is going through, right? So say you were standing right here, you would see that the arrows are showing that in high pressure area the winds are sinking and it's also moving apart, diverging. And then notice that in even if it's diverging, moving away, eventually it does rise up and then cause it creates these convection currents. So that's what happens with winds, right? We don't just stop. It doesn't just sink and stop there. The air is always circulating. Convection currents are always happening. Okay. And notice the low pressure areas. 0 degrees, 60-degree north, and 60-degree south are areas with low pressure. And notice that they are wet because low pressure air rises and that enables low pressure areas to form clouds and rain. Rain is and precipitation and storms are related to low pressure areas. In low pressure areas, the winds are also converging or coming together because remember, winds blow from high pressure to low pressure. Winds are always blowing towards low pressure areas. That's why you'll see in the 0-degree latitude, the winds are coming together. In 60-degree north and south latitudes, winds are still coming together. If we look at the atmosphere arrows, we see in low pressure areas like this, the winds are rising and then rising, moving away, sinking, and then coming back to the low pressure area, forming these convection currents. Convection currents are all over the world, okay? And this is how our Earth balances out the unequal heating of the atmosphere caused by the sun. So there are two extra vocabulary words you need to know. Arid means dry areas such as deserts, and humid means wet areas. So you might see these words a lot. Arid means dry, humid means wet. So in places with high pressure, we have dry areas or dry climate, right? And those areas are known to be arid. And places with low pressure are wet, right? Those places typically have rainforests, and those places are known to be humid. So, if we look at the rainforests throughout the world, we'll notice that most of our rainforests are actually near the equator. These greens are showing rainforests. And notice by the equator, we have low pressure. And in low pressure areas, we have so much rain and it's so humid that we can form rainforests in these areas. We're not forming rainforests all the way up here in 60° north and 60° south. Is because, yes, it's wet, but instead of rain, though, the water is actually turning into snow because it's so cold near to the poles, right? So we're not really forming rainforests there. But notice that if we look at the deserts throughout the world, most of our deserts are actually near 30° north latitude and 30° south latitude. And if we notice here in 30° north, we have high pressure and it's dry. And in 30° south, we also have high pressure and it's dry. So notice that the climate or the long term atmospheric state of many different locations of the world are determined by these high and low pressure areas. And the high and low pressure areas are forming because the earth is not heated up by the sun um equally. Some places are cooler, some places are warmer, and the earth is just trying to balance all that energy out with all the winds and all the circulation convection currents. So pause this video, try number 2. Which cross section best represents the general atmospheric circulation over the North Pole? The correct answer is D. Notice that in this page on your reference table, the North Pole is right here, right? That's 90° north. It doesn't label 90° for you, but the North Pole is always up here and the South Pole is always down there. And the North Pole is dry. There's not much humidity there or water there, and the air is sinking, meaning we have high pressure here, right? So it should look like this. The air is sinking and it's also moving away from the high pressure area. And once it reaches the low pressure area, it rises and then comes back to form convection currents. Pause this video, try number 3. The planetary surface winds and air currents near Earth's equator are usually. The correct answer is C, converging and rising. If you look at the equator, 0 degrees, in those areas in our atmosphere, the air is actually rising because there's low pressure there. That's why it's wet. And then it's coming back down and then coming back towards the low pressure area near the surface. Okay? And causing these convection currents. Try number 4, pause this video. Dry areas caused by sinking air and diverging surface winds are located at which two latitudes? The correct answer is C, 30° north and 30° south. Notice that in 30° north and 30° south, we have dry, and the air over here in the atmosphere is actually sinking, like you see over here, right? And it's sinking, but also diverging near the surface. It's moving away. Remember, high pressure air. In areas of high pressure, the air is moving away and it's moving towards the low pressure areas. And we're always getting these convection currents. Try number 5, pause this video. If a low pressure system follows a typical storm track across New York State, it will move towards the what? The correct answer is northeast. So remember, New York State is, or US in general, is around the 40° north latitude, somewhere between 30 and 60 right here, right? And then New York State and the US in general, our major winds, not all winds, just our major ones, actually blow towards the northeast. And this is why any type of storm, hurricane, or even high and low pressure systems eventually move towards the northeast because of these winds. All right. For this one, try to answer this question in the back of your worksheet and show your teacher for extra credit. Pause this video, write it down. So try number 6. Which table best shows the relationship between latitude and general climate conditions on Earth? Go and pause this video, give it a try. The correct answer is B. Remember, arid means dry and humid means wet, right? So in 90-degree north, that's the North Pole, we have dry or arid climate. In 60-degree north, right here, we have wet or humid climate. In 30-degree north, we have dry or arid climate. In 0 degrees, the equator, we have wet or humid climate. 30 degrees south, we have dry or arid climate. In 60 degrees south, we have wet or humid climate. Finally, in 90 degrees south, we have arid or dry climate. Notice that they don't tell you that this is 90-degree north and south, but the north and south pole are always 90 degrees latitude. So in the next video, we'll talk about jet streams.